So we'll go over the syntax of how to create a variable and sort of what you can do with it in a moment. But I want to review a couple things and also talk about how variables work. So before we do that, I'm just going to draw a little ellipse on the screen, or I'll draw a circle. And I'll put it at 200, 200, 200. Okay, so we have a nice big circle on the screen. And so far throughout the semester, we've been using functions like circle and rectangle and text and image. And we've been doing that to render graphics on the screen. And we've been using what's known as hard-coded values. Hard-coded values are just numbers, strings. There's other ones, but we'll just leave those for now. So numbers like the size or position of the circle, strings like the text that we want to draw or the font that we want to use. All of these things are values that don't change. Okay, so they can't change over the course of the sketch or over time. And so that's not the only thing that variables are useful for, but this is one of the main things that variables are useful for, is that variables can change over time. So a variable value can start as one value and it can change into a different value. This is an important component of programming because we want to be able to describe things to the computer that are more complex than just draw a circle or write some text. We want to describe animation and interaction and things that change over time, that move. So earlier in the semester, we talked about the difference between static and dynamic. Static means things don't move, they stay the same. We run the sketch and it just looks the same the entire time that it's running. Dynamic things change over time. And we need variables to make those changes happen over time. As long as we're using hard-coded numbers, changes can't happen. What we see at the beginning of the sketch is the same as what we see at the end of the sketch. The thing that's cool about digital media and about using the web and programming in general is that we can make changes over time. When you paint a painting in the physical world, you can paint it once and then it's going to look the way it looks forever. On the computer or in a digital context, we can have animation and interaction that's enabled by the computer making changes over time and rendering things. So when we make variations to the circle, to the size or the position, we're sort of abstracting. So these numbers are concrete. They represent a concrete value. Concrete, means it stays the same. So concrete values like 200 don't change. They represent the size or the position. What we're going to be using is sort of a layer of abstraction. So we are going to have a name for something that represents what it's being used for. So variables are abstract. You guys know the term abstract, right? You guys have heard that word before? Do you have a definition for it that you can think of? Yeah, it's like an idea. Abstract is kind of a tricky word. It's hard to define, but it basically means an idea. It's something that stands in for another thing, like it represents something else. There's other sort of colloquial uses of it as well. Let's see if there's a good... Yeah, this is about abstract for a paper. This is sort of the closest definition, but it's disassociated from a specific instance. That's kind of a confusing way to define it. But an idea, I think, is a good starting place. Something that's abstract is something that stands in for something else. It's a concept. It's not concrete like this number 200. 200 is the size of the circle. It's always going to be the size of the circle. It's never going to change. Something that's variable can change over time, and so we need a reference to that value so that the actual number can change. So let's try to implement that. And one of the things that we'll see in P5 is that it actually provides us with some variables. So just like we have our setup function and our draw function sort of added for us, there are also variables that are built into P5. And we can use those variables for different things. So the name of the variable doesn't necessarily change the functionality. So I'll give an example of that. So I'm going to draw the same circle. I'm going to make this circle a little bit smaller. And I'm going to draw the same circle. But this time, I'm going to draw it in the same position. But instead of using a concrete number for the size, I'm going to use a variable that exists in P5, which is called frame count. So frame count just tells us the number of frames that have passed since the program started. And that number is always going up. So it starts at 0, and each time we draw with the draw function, we just count up by 1. So it's a very simple variable, but it represents time. It represents something that's really useful to know. So if I change just that value, now we can see the size of the circle grows over time. So there's a couple things here that I've already kind of discussed, but that are important to understand. One is that even though frame count represents time, we're using it to change the size of the circle. So just because we're using something that has to do with time or the number of frames that are being drawn, that doesn't mean it has to be used to represent time. Right now we're using it to represent the size of the circle. So we can take measurements or values and sort of map them onto other things. We'll talk a little bit more about that in the second part of class. And we'll use a couple other variables, built-in variables. So things like frame count are called system or built-in variables. These are variables that are defined by P5 rather than by us. So frame count is a good example. Mouse X and mouse Y, those are the variables that represent the position of the mouse, are other examples. Those are easy to use. There's other ones that are a little bit more complex and kind of built into other structures that we haven't looked at yet. But we'll just start with these easy ones. So I'm going to do another example here. And this time I'm going to do a circle at 200, 200. And I'm going to put mouse X as the size. So you might be able to guess by just looking at the name of the variable what it represents. It represents the X position of the mouse. So it represents how far the mouse is from the left side of the canvas. So you can see as I move the mouse, I change the size of the circle. So if the mouse is all the way over here on the left, the X position of the mouse is 0, and so the size of the circle is also 0. As I move the mouse to the center, the circle gets bigger because the value of mouse X gets bigger. And if I go all the way to the right, then we see, the full size of the canvas. And with this, I can even go beyond the size of the canvas because it keeps tracking where the mouse is. So we can also do this with mouse Y. So now you can see my mouse is moving up and down, and the circle is getting smaller and larger. So it's a very simple sort of one-to-one relationship, which we can make more interesting relationships. Again, something we'll do in the second part of class. But you can see as the mouse gets farther down the canvas, the size of the circle gets bigger. So we're just taking one number, one measurement, and we're applying it to another property of our sketch. So we can actually visualize this number. So if I use text and draw mouse Y, I'll draw it in the upper left corner. You can see that number changing as I move the mouse. I'll make it a little bit bigger. Let's do 40. Or maybe 30. I guess I'll just move it down. Okay, so you can see when I move the mouse to the top, when it's right at the top, it's 0. And then as I move it down, we just see that number get larger. And that corresponds to the size of the circle. So again, we're using a variable. So instead of just having whatever that number is at the very beginning, we can apply we can change that value over time. And you can apply this to anything that has a number. So throughout the semester, we've been using lots of functions that use different numbers to represent different things, like color, position, size. Anything that's a number, we can change with a variable. I'm going to do another quick thing here. So I'm going to take out the background for a second. Okay, so we see that circle, the one circle that we're drawing, and now you can see what happens when I move the mouse up and down. Okay, so see how we get lots of circles when I'm making the circle smaller? We need to remember, as we're drawing this way, we need to remember that all we're really doing is drawing the same drawing over and over and over again, but we're doing it fast enough that it looks like it's moving. It looks like motion. So it's sort of like when you created an animation in M&P 100, or you've probably created other animations just for fun at some point. You're deciding what happens frame by frame, and then when you play back the animation, it looks like it's moving. It looks like it's real because we're putting those images together fast enough that it looks like movement to us as we watch it. With P5 and with programming, we get to add an extra layer to this, which is interaction. So we know where the mouse is at any given moment, and so we can tie the changes on what we see to the position of the mouse or the time of the sketch or other things. So I'll bring the background back in, and now it looks like we just have two circles again because we're constantly covering up those previous circles to create this sense of movement. Okay, so those are built-in variables. Let's create some of our own variables. So defining a variable. So we did do this briefly with our image assignment last week. We created variables to hold our image data. So now what we can do is define our own variables, and then we can change those variables over time. So I'm going to create a variable. So when we create a variable in JavaScript or P5, there's a few different ways to do it. One is with the var keyword. That's what we used last week. A better way to do it, at least these days, is with the let keyword. When we say let, we're saying let some value stand for, or let some name for our variable stand for some value. So I could say let x equal 0, and then I can update x. So when I create a variable, I want to name it after what it's going to represent. So let's put another, variables are named after what they represent. Okay, so we're going to have let x, and so I'll draw another ellipse or circle. And I'm going to draw this one at x instead of a concrete number. So now, instead of using a concrete or hard-coded number, I'm going to use a variable. And for the y, I'll keep it at 200, and for the size, I'll keep it at 100. So now I have these two circles, but the circle on the left isn't doing anything because x isn't changing. Okay, but we can change x. So let's say for x, we want to add a 1 for every frame, sort of like frame count. So I can say x equals x plus 1. This is a super common thing to do in programming, and we'll see other instances where we'll do this. Basically, what we're doing is we're saying x, take this value, whatever x happens to be, and add 1 to it, but then assign it back to x. So this is a little bit tricky, but if we just said x plus 1, it would do x plus 1, but x wouldn't change. X would still say 0. So something that we do very often is changing a value and then assigning it back to itself. This has its own special shortcut, but I'm going to leave it like this for now since we're just learning. So now when I say x equals x plus 1, we still don't get any movement, And this has to do with something that we talked about a little bit last week, which is that we had our variable up in the top of the program. So remember, with our image variable, we put it all the way up here at the top of the program. The reason we did that is because we wanted to use the variable in our preload function and our draw function. When we declare a variable like this, it only exists inside of the draw function. And the other issue that we're running into is that it's being set to 0 over and over and over again. So what we need to do is move this outside of the draw function so that it's not being redefined. So I'm going to select this part and cut and go and paste it up here. And so when we have variables up here, this is referred to as the global scope. It's like the main scope of the program. When we're inside of a function, we're inside of that function's scope. So if we make something in draw, it only exists in draw. But if we make something up here, it exists everywhere. Okay, so now we'll be able to see this work. And this is something that happens a lot. You'll make a variable and use it for something and then realize you need it in the global scope, and so you move it up to the global scope. So now we see our circle move. So every frame that passes, we're adding one number. We're increasing x by 1. So let's use our text to show x for now. So I'm going to say show variables. And so instead of mouse y, let's put x here. So you can kind of see the same thing. X just keeps going up. That number keeps getting bigger. And we happen to be using the number to say where the circle should be, the position of the circle. So again, if we take out the background, you can see that whole history of all the circles that we are drawing kind of streaking across the screen. But when we have the background in, we cover them all up so that we create this sense of animation. We don't have to increase by just 1, we could increase by 2. It'll move faster, or 5, or 20. So the more we add to the number each time, the farther it's going to move because the number is just getting bigger. So we can define a variable and move it around like that. Yeah, so if I update that number, it's going to go faster because we're moving farther each frame. And so we can do this with any of our variables. And what we want to start to do is use variables as a sort of way of designing stuff. So I'm going to do another example. I'm going to leave this here for now. I'm going to do another quick example where I'm going to create a simple drawing, but I'm going to define everything relative to a position. And by doing that, it'll allow me to move the drawing around on the canvas. So I'm going to create a new sketch, and I'll call this position variables. And so what you'll realize once you see this working is that this is how every video game you've ever played, every interactive thing that you've ever seen, this is how it works. Okay, so we're going to do some position variables. Okay, so let's say I have like a character, and the first time I define the character, you might just use hard-coded numbers just to get it to look like how you want it to look. So let's say I have a character. I'm going to do like a little frog character. So I'll do green fill, and I'll do a circle, or let's do an ellipse. Let's make our frog a little bit wider than it is tall. So we'll do an ellipse in the middle of our canvas, and we'll make him 100 pixels wide and 40 pixels tall. Okay. Oh, I wrote fill instead of green. Whoops. Okay. So let's do no stroke. Okay, so we've got the body for our frog. Let's put a comment that says body here. Let's add some eyes. So I'll do a circle. And if I want a circle for the frog, I'm going to want to move it a little bit up and to the left. So I'll do like 200 minus 20, 200 minus 20, and I'll just make it like 10 pixels, maybe a little bigger. Okay, so that's the left eye. And so again, what I did there is I just took the center of the body, and I know I want the eye to be a little bit to the left of center and a little bit up higher. So I subtracted 20 from X to move to the left, and I subtracted 20 from Y to go up. And so for the right eye, it's going to be pretty much the same thing, but on the other side. So I'm just going to copy and paste this whole line, call this the right eye, and then for the X, I want to move over to the right instead of minus to the left. So now I've got two eyes. Let's add some feet. So for the feet, I'll do some ellipses. I'll do an ellipse. And so for this one, I'm going to want to move down and over. So for X, I'll say like 200 minus 40 maybe. And to move down, I need to increase Y. So I'm going to go up. So I'll say 200 plus, try 40 there. And then my feet are going to be a little bit wider than they are tall, so I'll do like 20 by 10. Okay, that's a little too far away, so let's bring it a little closer. And let's make it a little bit bigger. Okay, that's a little too big. Okay. That looks good. That's the left foot. And so just like I did with the eyes, I'll copy this and paste it. And then I'll go in the opposite direction. So instead of X minus 30, I'll go X plus 30. So now I've got some feet. And now I've got a little frog. Obviously, I could add more to this, but I'm just going to, stop here. So I have my frog design. And right now, the frog is just a static frog. It can't move anywhere, right? So it's pretty boring. But if I wanted to create a game with my frog or an animation with my frog, what I would need to do is figure out how to make these values that set the position and the size variables. So I can change these values. I can move this guy over here, but then it's just over there. I can't update it over the lifetime of the sketch. So this is where we want to add some variables. And because everything is related to this center point, 200, 200, I can just use that as kind of the center point, starting point for my values. So I'll go back to the global scope. So remember, I want these to be able to change. So I don't want to define them in draw, because draw is always running over and over again. So if I define them in draw, they'll get redefined, which is not what I want. So I'm going to say let x equals 200 and let y equals 200. So again, I'm just declaring my variables. So let's put a note here, declaring variables. So declaring variables is saying they exist, but we're also defining. So when we say equals 200, that's defining a variable. So declaring and defining variables. There's a big word for this, which is called initializing. Initializing is when you declare and define at the same time. So you'll hear initialize when you see a variable like this. But we're basically just saying x is a thing that exists, and the value we want x to have is 200. And so now we need to replace all these numbers. So I can say x, anywhere that I have an x 200 or a y 200. For the size, that doesn't really matter. Right now, we're just worried about the position. And remember, we always go x, y. So x is always the first value, y is always the second value. So this 200 is x, this 200 is y, this 200 is x, this 200 is y. Notice that I'm just leaving these minus 20 and plus 20 because I want those relative positions to be the same. So then I'm going to put x and y here and x and y here. One of the things you'll notice when you start to use variables is that your program is easier to understand. It's pretty obvious what x represents, whereas previously when we just had the number 200, it's not obvious what 200 represents because 200 could be anything. It could be a position, it could be a size, it could be a color. But when we have x, when we choose the name of the variable that we want to represent the position, we can make it whatever we want. So if you had multiple characters, you could have this be like frog x. You can say whatever you want for the variable so you can make it clear what it represents. And so now our code is a lot easier to understand because we know what xy means. It means the position. And we know what x minus 20 is. It's taking the position and then moving to the left. As opposed to 200 minus 20 doesn't really mean anything in and of itself. So if we use variables and we name them well, our code will be a lot easier to read. Okay, so now our frog can change, but it's not going to do anything just yet. If I change x, our frog will move. If I change y, our frog will move. But it's not going to change until we change the variables as our sketch is running. So let's look at two different ways to do that. So one thing I could do is I could just say x is going to be mouse x, and y is going to be mouse y. So I can just set these values to anything I want. And mouse x and mouse y are going to be changing throughout the program. So if I do that, now my frog will move with the mouse. So that's one way to move the frog around. So frog moves with mouse. I'm going to comment these out for a moment. We can also just move the frog. So we could say x equals x plus 1, y equals y plus 1. So now the frog moves on its own. This would be good for animation. We can't really do much more than just move it off the screen right now, but we'll learn how to do more interesting stuff with it soon. So frog moves on its own. Another thing we could do is we could look for a different type of event. So these two events are continuous. The mouse is always changing. The draw loop is always updating. But sometimes events just happen at a specific time. We've seen this in the past when we use mouse pressed. So let's use mouse pressed again. So I could have a function, mouse pressed, and I could say whenever I press the mouse, then let's define x and y according to where the mouse is. So I could say x equals mouse x, y equals mouse y. So now instead of happening continuously, this will only happen when I click on the screen. We'll look at where is mouse x, mouse y, and we'll move our frog to that position. So depending on what type of interaction you're creating for your user, you may want to use different types of events to update your values. All right, so this is just one example, and we're doing something very specific, which is changing position. We also looked at a little bit at changing the size. Later in class, I'm going to go over using the map function to map one range of values to another. This is a little bit more complicated, but it's still relatively easy because P5 really does most of the work for us, which is really convenient. So we'll look at that in the second part of class. For now, I just want you guys to kind of play around with these variables. Our assignment for this week is very open-ended. It's just to make an interactive design. And so this is just a sketch where you could have shapes, you could have colors, and they should just change in some way based on the user input. And I want to leave it kind of open-ended because I want you guys to just try to think about what would be an interesting thing to happen. It doesn't have to be super complex. It doesn't have to be, anything super complicated. But there should just be some type of interaction. If you move the mouse, if you click on the screen, that changes the design in some way. So it updates the color, it updates the position of a design or a component, or something like that. So there's a lot of different ways you could do this. You could combine multiple ones of these things. So let's say maybe the frog is always moving, but we also click, and so it changes where it moves. You could add multiple variables. So I've only created one frog, but you could have multiple frogs drawing at different positions. You could change the size. There's all sorts of different ways that you could update the way that the sketch looks. So for now, just play around with it and see what you can come up with. In the second part of class, we'll go over the map function, which gives you a little bit more control over what happens with an interaction. And we'll have some more workshop time as usual. So I'm going to stop